Hello, everyone. Hope everyone out there is doing great today. Today, I'm going to talk about some facts about space because I love space. Oh, that's weird. My marker's doing this like double thing. It's kind of cool. It's like two lines. Okay. So there's going to be 22, I think, if I counted right. So the first one is the moon is actually lemon shaped. Like that. Despite what it looks like in the sky, it's actually nowhere near round. The moon is shaped like a lemon with like flattened poles and then bulges near the near and far side of its equator. It's thought to have been shaped like this shortly after formation because of its interactions with like the earth and the gravity of the earth. That's really weird. I like had no idea. Some of these I'm like, am I just like out of the loop? Or does anyone know this, you know? So this one I think I may have heard of before. The Milky Way has a smell. And it smells like raspberries. Like rum and like booze, alcohol. This is because when they were doing research, they found like this gaseous cloud near the center of the Milky Way. It was filled with a chemical known as ethyl formate, which is what is responsible for giving raspberries their flavor, and also rum. Like, it smells like rum. So close to this region that the cloud that they like took the sample from, there's also like an abundance of ethyl alcohol or ethanol. And this is the type that we use to make like alcoholic beverages here. Interesting. It makes sense that like everything we use would have like properties that existed in the Milky Way and like the universe, but it's just interesting to like connect those dots so specifically. So it has enough alcohol to supply every person on the planet with 300,000 pints of beer per day for the next billion years. I don't actually drink, so like every once in a while I'll have a drink, but I don't drink very much because it like makes me sick. It just makes me feel like I'm gonna throw up all the time. So if you were to like consume this, which I don't know how you would, or if that would be a good idea, it would only be less than 1% alcohol. Oh, I could have just done the sign. Because you would also, but it would be bad because you would also get like carbon monoxide and hydrogen cyanide, which would at least give you like a headache. So the third fact is on Mercury, One day is twice as long as a year. Technically, one day on Mercury is 59 Earth days. Dang. And a year lasts 88 Earth days. However, Mercury has a very unique orbit in reference to the sun, so its orbit isn't like Earth's orbit. The length of time from sunrise to sunrise, known as a solar day, is equal to 176 Earth days. So, because of its orbit and like the way it turns, it's like facing the sun that whole time. Because a solar day means that it goes all the way around from sunrise to sunset, back to sunrise. So, then it's days for a solar day, which is twice as long as one of its years. So it's interesting. So the next interesting fact, number 4, is that you could survive in a spacesuit that has like a leak in it outside in space for several minutes. A lot of movies have depicted like crazy stuff that happens when you get a leak in your spacesuit, like your cells exploding and like the oxygen getting like sucked out immediately and stuff like that. But you could actually survive for a couple minutes. So after around 10 seconds, you would lose consciousness. So although this would not be fatal, the pressure of the vacuum would cause your blood to boil. Along with other body fluids. But there's like pressure maintained by our blood vessels, and so it wouldn't actually like kill you right away, or at least it wouldn't kill you as fast as like the other things would. So then gas bubbles would form in your body fluids. So you would like swell up and bloat, and then the low humidity of space would cause you to cool down super rapidly. So like your eyes may freeze. Then after a couple minutes, the lack of oxygen itself would be the thing that would probably start to kill you. And there would be like decompression to your lungs, eardrums, and sinuses. So you could survive, but it would really be like kind of a bummer. And it would be horrifying to experience that and then have to like, I'm sure you would have like nightmares about that for a long time. I would. So the next one is 1 teaspoon of a neutron star equals the same as the human population together. I mean, stars are crazy, you know? So this is a neutron star, is also known as a pulsar, which I'm sure people may have actually heard that more. Which neutron stars are crazy. They're like composed almost entirely of neutrons, and they're packed together super tight in a tiny nucleus, which is just like very unique. So a teaspoon of this would weigh over 1,000,000,000,000 kilograms. And the weight of the entire human population actually only reaches a few 100 billion kilograms. Billion. So it's so dense that in order to make the human population as dense as a neutron star, you would have to pack every human into the size of a sugar cube. It's a gruesome thought. This one's interesting. I like that one. Number 6. Gamma ray bursts. Release more energy in 10 seconds than our sun will in its entire life. So this is considered maybe one of the most powerful things that can happen in the universe. Gamma ray burst. It's a brief but incredibly high energy, intense flash of radiation. Intense flash of radiation. But it's like high energy, so it's like, obviously, it's one of the most powerful things that can happen in the universe. So there are multiple types of gamma ray bursts. One of them is when, this is all like theoretical physics, by the way. The first one is thought to be when a massive star implodes. The other one is thought to be when 2 neutron stars merge together. So 2 neutron stars I would love to see that from a distance. Or if I could safely see it up close, I would see that too. It'd be scary. I think this is number 7. There are stars we'll never be able to see. I think probably some people would know this. Part of this is because the universe is continuously expanding. And if you think about it, it kind of makes sense because the Big Bang was an explosion, and explosions usually continue to expand for quite some time. And so that's kind of like what's happening still. So stars that were formed at the beginning of the universe will probably never see because they're so far away and they continue to expand at an accelerated rate. So it's interesting. This part always kind of scares me about space, but I can't even like begin to understand it, so don't let it scare you. Black holes have theoretical opposites called white holes. Black holes are known for being like vicious and like nothing can escape their gravitational pull, including light. White holes theoretically would be spitting out matter and particles. So a black hole kind of like deconstructs things into their most basic particles is like what we think. And then a white hole would be spitting out particles and light. But this is theoretical still, so like I don't believe there's any actual evidence that we've seen with like a telescope or anything. So we can't like prove that that exists yet. This one I thought was really interesting. Planets can wander through space without a parent star. So obviously a parent star would be a sun that it was rotating around. Astronomers estimate that there could be over 200 billion planets just floating around through space without a sun. They can also be called rogue planets, which I love. And they're thought to have been like ejected from their solar system, like kicked out. It's kind of sad. Our sun loses 1 billion kilos per second. This is because the upper atmosphere of the sun is so hot and like full of energy that particles on the surface speed out into space in like solar winds. So our star loses about 1.3 trillion particles per second. This could equal 1 billion kilograms of matter per second, or 1 Earth every 185 million years. Which seems like a lot, but this is all just nuts. You know what I mean? It's just nuts. So most sun-like stars in our galaxy are multiple star systems. Like every sci-fi we've ever seen. There's like multiple suns. Our single star sun is actually a minority. A lot of sun-like stars in our galaxy are binaries, so it has 2 or triplets, so 3, and they're orbiting around a common center of mass, which, I guess it could be like a black hole. A lot of lower mass stars like red dwarfs, though, live alone without a twin or a triplet. 13, there's actually a lot of water in space. More than we would think. Which is interesting because our planet could run out of water, which is one of the like main problems out of many. You could actually, there's so many like sci-fis where people are harvesting water from like a solar system, or like it's like something so common in sci-fi that could like be a possibility. That's just crazy because there's water in space. There are oceans, Jupiter's moons, and 2 of Saturn's are thought to have like underwater oceans and seas. Europa's ocean may contain over twice the volume of the oceans of the water that's like on Earth. So there's actually a region in space that we've discovered that has water surrounding a black hole, and this area has vast amounts of water vapor. It's over 140 trillion times the volume of the water that we find here on Earth. Number 14, our days are getting longer. Earth's spin is slowing every year. It takes our planet a little longer to complete one full revolution on its axis. It's very small, so every century Earth slows by 1/500th of a second. So every 1,000 years, one day will be 2/100ths of a second longer. I've stopped numbering because I forgot the number. So the moon is getting farther away every year. I'm just gonna read this description because it's like kind of confusing. So the moon exerts a pull on the Earth, causing our planet to be slightly egg-shaped. It affects water by creating tides and causing the oceans to pile up towards one side of the planet, forming what they call a tidal bulge. This bulge is dragged around the moon, like with the moon as the moon orbits the Earth. The Earth rotates faster than the moon, 24 hours versus 27.3 days, which is the moon. The bulge moves slightly ahead of the moon's position in orbit. So weird. So the moon pulls back on it, effectively trying to slow it down and causing the Earth's rotation rate to gradually slow down over time as a result. As the two bodies interact through gravity, this tugging causes Earth to lose energy while the moon actually gains energy. Because of this energy boost, the moon is slowly spiraling outwards, moving away from us by 3.8 centimeters per year. It actually seems like a lot, doesn't it? I know space, right? But so there's still heat from the Big Bang. It still exists. The actual heat that was formed because of the Big Bang. The universe consisted of ionized gases and sort of like an opaque plasma is what they believe. About 380,000 years after the Big Bang, which is a really specific amount of time, which is interesting, gas cooled and could actually form atoms. So, cooled and formed atoms. When they talk about heat, they're really talking about like radiation, which is heat. It's still around us today. It's known as the CMB, or the cosmic microwave. Oops. Cosmic microwave background. I guess I've never thought about this before. Venus spins, they say backwards, but it's really, I don't know. Compared to us, it's backwards, right? Guess they could spin either way. So this is actually the only planet in our solar system that spins this way. All the other planets spin the same way that Earth does. They're trying to figure out why. They think maybe it could have been like hit by another object, sending it spinning in the opposite direction. This is another weird one where Venus spins really slowly. So a day is equal to 243 Earth days. And a year is equal to 225 Earth days. So again, a year is going to be shorter than a day. Isn't that interesting? It just depends on like the rotation of the planet. So this is the last space fact I'm going to talk about today. Our sun is pretty big, but there's something called red hypergiant stars that are 5 billion times the size of the sun, and one of them is called UY Scuti? Scuti? I don't know. So we consider this the biggest known star in the universe, in the known universe, so the universe that we know. There's so much more than we can see or even know. It's unbelievable. If this were to replace our sun, it would like be larger than past the orbit of Jupiter. It would encompass 5 billion suns, 7 trillion Jupiters, or 7 quadrillion Earths. So that's the scale of the size of this sun. UY Scuti. Oh, there's some weird. Okay, this fact is really weird. I'm just gonna say it. Our solar system has a wall called the heliopause. It's a region in space in which solar wind isn't hot enough to push back the wind of particles coming from distant stars. It's like a force field or like a barrier. It's often considered the boundary wall of the solar system and interstellar space. So that's the last fact I have for you today. Space is amazing. It's also incredibly terrifying. It's something that I don't allow myself to think about at night before I'm going to sleep because there's too much that like we don't understand and I'll never understand, and my mind will just like go on a roller coaster. So I'll be up for hours. Thank you so much for joining me today for this lesson on interesting space facts, and hopefully I'll see you in the next video.